You're going to be given an equation, and you're going to have to figure out where the asymptotes go on a graph, okay? So yesterday was easy because we looked at the graph and we could easily see what the asymptotes look like. Today is still easy, but you're going to be given an equation, and I'm going to give you 3 simple rules that will help you determine where the horizontal asymptotes are. Now, does anybody remember what makes a rational function? How do we know, I guess what I'm saying is, like, we study polynomials, right? Well, polynomials don't have horizontal asymptotes because they're not rational. So, very good. So we know if there's a variable in the denominator, we can look out for horizontal asymptote. So whatever's up here, it doesn't matter, x cubed plus 7 or whatever. It'll be rational, and we can therefore look to see where the horizontal asymptotes are. Now, polynomial, for example, might be like f of x equals 3x to the 4th minus 2 or something. That doesn't have a denominator, so it's not rational. It's not going to have a horizontal asymptote. Now, there are other types of functions that do have horizontal asymptotes, which we will talk about later on in this class. For example, a exponential function actually has a horizontal asymptote. Here's the first rule you need to write down in your own words. And this is the easiest one. If you look at a rational function and the highest power in the numerator is larger than the highest power in the denominator, it will not have one. So let's read this function together. F of x equals 3x minus x cubed over 2x squared plus 1. The highest power in the numerator is 3. The highest power in the denominator is 2. 3 is bigger than 2, right? So it won't have one. It's that simple. Any questions on that? Now notice I didn't look at the first power. The first power on the top is 1. I looked at the biggest. So again, highest power on the top is larger than highest power on the bottom. There will be no horizontal asymptote. Now the reasons for that go back to calculus, which you haven't learned yet. So I hate teaching a lesson where you don't know where it comes from. It goes back to the limit, for those of you who are listening in calculus side. The limit determines the fact that this will not have a horizontal asymptote.
So if the bottom one is smaller.
If the bottom one is smaller than the top, yeah, you could say it that way too. It will not have a horizontal asymptote. We know from calculus it'll tend to infinity or negative infinity. But anyways, that's the rule for that. Highest power on top is equal to the highest power on the bottom. You are going to divide the coefficients to figure out what the horizontal asymptote is. So here I have everything circled here, but let's read this function. G of x equals 3x to the 4th minus x squared over 2x to the 4th plus 1. What's the highest power on top? 4, right? Highest power on the bottom, 4. They're equal. So the rule is you divide the coefficients, and the coefficient means the number in front of the variable. So I'm just going to divide the coefficient of x to the 4th on top, which is 3. Coefficient on the bottom of the x to the 4th is 2. So your horizontal asymptote, you could just write it as y equals 3 over 2, which as a decimal is what? 1.5. So if you were to go to sketch this graph, you would sketch a horizontal line at y equals 1.5. Dotted line. 3 is the coefficient of x to the 4th, which is the highest power on top. That's only if the powers are equal. There's one more rule we're going to go over after this. When you go to sketch this asymptote, you'll be using a dotted line, not a solid line, because remember, an asymptote is an imaginary line. So just keep that in mind when we go to sketch these. And then the third rule, if the power on the bottom is bigger than the power on the top, it's always going to be y equals 0, or you can write f of x equals 0. So let me explain this example. What is the highest power on top?
1.
Right, so x there's no 1 there, but it's there, right? You just don't see it. X to the first. Highest power on the bottom is 2. Okay, 2 is bigger than 1. And so according to this rule, the horizontal asymptote will just be y equals 0. And it doesn't have to be, I mean, it could be 5 on the bottom and 2 on the top, as long as it's bigger. The reason for that, again, goes back to calculus, but you can kind of imagine that if the bottom is going to be bigger than the top as x gets bigger, because you're dividing by a much bigger number. If you take a smaller number and divide by a bigger and bigger number, it's going to approach 0. You can investigate that if you want, a calculator or something. Anyway, it's going to become a really small decimal. Yes. All right, example 1. Can anybody tell me right off the bat what the horizontal asymptotes are going to be for h equals 2 over 3x? Huh? Nope, you're not dividing coefficients. 0, because the power on the bottom, there is no power on the top, right? It's basically x to the 0, more or less. So if it's just a constant on top and x on the bottom, that means the power on the bottom is bigger. So it's going to be y equals 0. Okay, so that rule, we're applying that rule because technically the power on the bottom is bigger than the power on the top. So you can write y equals 0 or f of x equals 0, whatever, it's the same thing. Any questions on that one? I did that one because it wasn't quite as obvious. You know, there's nothing on top, so you kind of have to fill it, the missing information in. All right, how about this one? We have 3x squared minus 2 on top and 5x minus 1 on the bottom. There is none, because why? The power on the top is bigger than the power on the bottom. So there is no 1 down here, but we can fill it in right there. And that means that the power on the top, highest power on the top is bigger than the power on the bottom, so there will be no horizontal asymptote. It's going to tend to infinity or negative infinity, like I mentioned. And then the last one, what is the highest power on top? 5 is biggest on bottom, at top. 5. Okay, let me ask you guys, is it positive 8 over 28 or negative 8? Yeah, you got to carry the sign with it, okay? So you're going to take the coefficient of the x to the 5th, which is negative 8, and divide by the coefficient of the x to the 5th on the bottom, which is 28. And yes, you do need to reduce, okay? Negative 8 over 28 reduces to negative 2 over 7. So for this one, you're going to have a horizontal asymptote at y, or f of x, equals negative 2 over 7. Which, if you reduce to a decimal, would be around negative 0.28. I'm just estimating there. So any questions about these 3 rules before I give you guys the assignment?